Hi everyone. Now in this video let's have a look at rolling window and recursive or sequential regression analysis. Now I won't do analysis here, I will just describe or explain you how we could write a code in Eviews to run rolling window recursive analysis. Now there are different software packages where you could have built-in functions. For example, in Eviews there is not any no functions of such function, I would say. Or in Stata you would have, in R you would have, in MATLAB you would have to write one up. But for Eviews users this would be very helpful, hopefully. So let's start with this. I mean, you know how to use it, or for what you to use the rolling window analysis. I'm not going to comment on it, but let's start with this. So first, when you write in this code, set your sample here. If you're doing some other analysis and your sample may have been different here, so if you set the sample, this will just set it back to the original range. And start with determining the length of window. For this one, this is the fixed window length basically. It's the size of the rolling window. And for this, you need total observation numbers. So I just took one of my variables, which is in this case GDP. This would count the observation numbers and then fix it to this control variable, or assign it to this control variable, and then decide what length size of length is for your regression in each loop or in each run-off loop. So in this case I did decide to choose 100 because it's easier to work with hundreds. Then next thing is, for your loop you need regression numbers, or number of regressions to run over your sample. So let's say we have 1,000 observations. Then how many regressions you have to run over these 1,000 observations given the fixed sample fixed regression size in each loop. In that case, this would be this formula basically for you to use to determine the number of regression in the loop. Now this would be total size here 301 minus I should say this is actually 300, isn't it? That's 301, sorry, observations. So this would be 301 minus the size, which is this, so 201 regressions plus 1, 202 regressions. Basically, if you do not do the plus 1, you will end up having 1 observation drop here. So the last observation will not be included in the regression. So add this on. I mean, I did experiment with it, and you need this plus 1 here. Okay, now, well, basically this is actually what we call time varying parameter vector recursion model here. I'm running now for my own purposes. So these are my matrix of coefficients, or I'm going to say the coefficient of the matrix is, and as you can see, this one has 5 rows, basically 5 variables with this many columns. This is the number of regressions. In each regression, I'll get some estimate of number of coefficients, and I will say them here. In fact, I just was doing this, so these are here basically. And you start the loop now. In this case, the loop will be going from 1 to the total number of regressions in your given your sample size. I mean, fixed sample size. So this is a regression number is basically this calculation here. And first start with rolling window. Rolling window is what it does is starts from the first, let's say loop is 1 now, so 1 to 100 plus 1, which is 101 minus 1 gives us the first sample is from 1st to 100th observation, runs over it, calculating all these things, goes up to here, next goes back, I is equal to 2 now, then it starts from the second observations, and 100 plus 2 gives us 102 observations, minus 1 gives us 101 observations. So the second sample is actually the sample size, fractional sample from the second up to 101, and third will be from third to 102, so on and so forth, and it goes on in that fashion, fixing the samples at 100, and basically you end up having some sort of coefficient estimates over time in this case. And in other word for the rolling window analysis actually is a kind of term that we usually use is time varying parameter regression analysis. It's a fancy one, but yeah, it really is rolling window if you're doing non-Bayesian analysis. If it's Bayesian, it really is a time varying, proper time varying. Anyway, so here it is. Yeah, So you just run this in this fashion with this sample counter. Next, let's run it, by the way. Run. As you can see, yep, sample size is changing. Last sample size sample contains observations from 102 to 301. Each time it's 100 observations. How do I know 100 observations? Could just be the last observation, the last sample having 100 observations, and everything else is different. For this purpose, just have some sort of observation counter here, which I call sample with double L here, just to keep it differently. And this will count basically each time the size of the sample, in each loop, in each run of the loop, and it is saved here. As you can see, I have this is basically the size of sample over each regression, and I have 202 regressions each time it's 100 sample, which is fine now. I'm happy with it now. Okay, go to the next one. I'll just comment it out and then go to the next one. This is actually recursive window analysis. In this case, recursive model, you will fix the first sample point observation basically. Here you didn't do that. You just let it vary all the time over the loop points, and the window is moving all the time with a fixed sample size. But in this case, sample size is not fixed actually. First sample basically is from the first observation to 100th observation when it's I equal to 1, and it keeps increasing without incrementing, but without deleting one observation from previous sample. So you will have basically this one fixed and this one increasing all the time. So first loop you get 1 to 100, come back, second run of the loop 1 to 101, third 1 to 103, and so on and so forth up to 103. So you can actually try and test this as well. Run. Okay, as you can see, it's fixed to 1 and up to 301. And this last one has 301 observations, whole sample basically here. And I can test this as well. As you can see, my sample size increases in each regression by 1 observation, and it just comes up to this point, 301 in the last regression. Right, so this way, basically you can study the coefficient stability or other certain issues in your data. And what else here? By the way, you could basically do a lot of things basically. I was going to say something here, but I think I'll leave it to other video. This would complicate otherwise. So by the way, yeah, coefficients, for example. If you're saving coefficients, for example, I have saved this is basically normalized long-run relationship or long-run coefficient estimates here for each regression. So each sample here basically, each regression has a certain sample size. So this is 100 sample size of 100. This is 101, 102, 103 because of recursive regression. I have 202 regressions. Don't I? Yeah. So I would usually save them for analysis, and I guess you could save t-values. You could save anything else as you wish. Anyway, hope this helps you to do your own rolling window analysis, or I would say what we call is transmitting time varying parameter analysis. See you next video.